Hello everyone, my name is Sonakshi, and in this video I will be describing various examples of maps and explain each of these maps based on their scale, their projection, and the coordinate system that has been used. So let's move on to our first example. So my first map is a Rochester crime map. So as you can see here, it's a Rochester crime map, and since it shows like little intricacies and all the details, so it's a large scale map. We are showing the city of Rochester. It is showing all sorts of crime like that have been occurred in a specific locations of Rochester. So if you can see, if I click here, you can actually see all these locations by their address. So there is this much of detailing in this map. At the bottom left corner, you can see a graphic bar scale which changes as the size of the map changes. So when I zoom in and zoom out, this graphic scale adjusts itself accordingly. And at the top right corner, we have been given like various options, and one of them is a legend. So these colors are showing like various crime types. So like red is murder, gray is robbery, and then you can also filter these crime type based on like number of days you want. So if you want the report for the last 14 days or last 30 days, etc. So let's talk about the projection of the map. So the map shown here represents the conformal or Mercator projection. As the distortion you can see is affects the size and area of the map. However, the shape and angle is preserved in here. And talking about the coordinate system, we have a state plane coordinate system in here, as it is based on the specialized zone. I mean, it is not going out of zone, and like no particular area is showing more than two zones. It is defined by the political boundaries. So it's a state plane coordinated system. So that was our first example. So let's move on to our next example. So this is again a crime map which represents the crime, but on it represents the homicides and murder rate, but for the world level. So we have our legend here in the bottom left corner, which shows the level of crime in here. So as you can see, the data is like very high level, and we don't have like much of an information about every region and like details of crime based on every region. So it's a small scale map. Talking about the projection of the map, it is an equal area projection, so where the area and size of the continents are preserved. However, the shape is distorted. Also, the properties like directions are also distorted in here. For the coordinate system, we have our latitudes in here. We have our longitudes. I mean, it's a bit light, but you can see that, and it's shown on a 3D space, and thus it's a spherical coordinate system. Moving on to our next map representation. So my last example is a world precipitation map for the year 2012. Again, as you can see, we do not have a detailed information for every specific region. So all we can have is the high level understanding of the precipitation level in various continents. So it's again a small scale map. with only high level understanding. At the bottom in here, you can see the graphic, the legend showing the range of the precipitation with different colors. Light yellow showing the least precipitation, and the dark pink shows the maximum rainfall. And these colors are then distributed over the map. Moving on to the projection type for this map, it is showing a conformal projection, preserving the shape and the angle of the map, but not other factors like direction, etc. And for the coordinate system, we have our universal transverse Mercator planar coordinate system in here, where the map is divided, as you can see, the map is divided into zones. However, this coordinate system do not conform to political boundaries or jurisdiction, as you know, like it's a drawback for the UTM planar coordinate system, that it does not conform to any political boundaries. So yes guys, that's it. Thank you so much.